मैडम को देखो नहीं कौन है। हाँ, गुड आफ्टरनून मैडम।
Yeah, good afternoon. Can you hear me?
Yes मैडम, yes, नमस्ते जी, नमस्ते।
Namaste.
So if you want to test any presentation madam,
Yeah, I can try sharing.
yes please share it so that I'll just say you whether it is coming out clearly or not. इथे काही असतील असं थोड़ा ओहो ତାକୁ ତାହେଲେ ଏପଟେ ଟିକେ ରଖୁନ କଣ କି ରହିଲା କଣ ବୁଲିବି ଲେଫ୍ଟ ବୁଲିବି ନମସ୍କାର नहीं नहीं चलो हाँ कौन आज ଯିବ କି କୁଆଡେ ଆଚ୍ଛା हाय
Hello. Hello.
madam, yes madam.
I'm not able to share my screen.
You are not able to have you seen the share button madam?
Yeah, but share this window, it comes and then I'm not able to, it doesn't ask me and it throws me.
Then you just send me your PPT to my mail also. In case it doesn't work, that I can present from this side.
Yeah, hello. It says there is some problem in sharing.
Uh-huh.
And it is
one
throwing me out.
Yes, one thing you just do, madam. Please send your PPT to my mail ID. I have just sent a, you know my email ID, and I will try to present it. And one of our computer person is also just coming. I think she may guide you. Or one thing you do, please get out from the link and rejoin again, and
That's
then
what
try.
That's what I did. Let me see. Are you able to see my screen now?
Yes, madam. Yes. Please go to the second slide. Yes, it is working.
Yeah. Okay.
It is working. It's fine. So we'll start sharp at 4:30, madam.
Yeah. Okay.
Okay. हाँ, 123. So good afternoon to all of you and welcome to the 11th SOFAL 4 series of oration, and this is overall 86th Sikha and Anusandhan fortnightly academic lecture series. Today we are very privileged to have amongst us one of the Lilavati's daughters, Professor Dr. Annapurni Subramanian, and I have the privilege of introducing the speaker briefly to you. Annapurni Subramaniam is the director of the Indian Institute of Astrophysics, Bangalore. She was awarded Rashtriya Vigyan Puraskar Vigyan Shri in 2024 for space science and technology. She has about 3 decades of research experience and has published about 175 research publications in topics such as star clusters, stellar populations, galaxies, and ultraviolet astronomy. She has trained a large number of students for projects, and she has guided 15 students for PhD, and several collaborated with her for thesis work. She is currently the chief editor of the Journal of Astrophysics and Astronomy, jointly published by the Indian Academy of Sciences and Astronomical Society of India. She is also a scientific editor of research in astronomy and astrophysics published by the Chinese Academy of Sciences. She heads the membership committee of the International Astronomical Union. She was involved in various space missions, including AstroSat and Aditya L1. She has contributed to the 30-meter telescope TMT, which is being built by an international consortium with India as a partner. She is the principal investigator of the proposed next generation UV optical space telescope, INSIST, leveraging on the experience gained from AstroSat and UVIT. Some of the achievements she has to her credit is awards and fellowships. Fellow of the Indian Academy of Sciences in 2014, Fellow of the National Academy of Sciences since 2013, Life Member of International Astronomical Union and Astronomical Society of India, Kavil Frontiers of Science Alumni instituted by Kavli Foundation and National Academy of Sciences, United States of America. Recipient of C.V. Raman Young Scientist Award for Physical Sciences from the Karnataka government for the year 2018. Recipient of SAR Power Fellowship 2021. Recipient of Nasi Bhuti Foundation Lecture Award 2021. One of the top 100 women achievers of India, India Today, December 2023. Devi awardee by the New Indian Express, January 2024. Future Forward Female Award from CNBC News 18, February 2024. For the informations of our new viewers, let me tell you that the Sikha and Anusandhan Fortnightly Academic Lecture was conceived years back in February 20, 2021 under the this was actually the brainchild of the then Vice Chancellor, Professor Ashok Kumar Mahapatra. And since then, uninterruptedly, we are conducting this SOFAL lecture series. And today, we are actually in the 86th lecture, the oration of the SOFAL 4 series. The first series, for 1 year after the completion of the first series, we published the 25 lectures compiled into volume 1, aptly named as SOFAL Mala. And the next 25 lectures was published as volume 2, and the next 25 lectures were published as volume 3. So this has a special annual theme of Lilavati's Daughters, Women Scientists of India. As all of you know, this is a very famous book written by Rohini Godbole, and Rama Ramaswamy. This has already been translated into Odia, and it is awaiting the acceptance by the Indian Academy of Sciences, and after which it will be published by them. So with these, I am also thankful to our Chancellor, Professor Amit Banerjee, who is with us. I am also thankful to Professor Subhankarji of the Academic Trust. Maybe in the audience we have His Excellency Ambassador of Syria. And so with these words, before I hand over the platform to today's speaker, I will request our Chancellor, Professor Amit Banerjee, to kindly speak few words. Sir.
Thank you and good afternoon, Professor Annapurni Subramaniam. It is a great pleasure and privilege to welcome an illustrious speaker like you this afternoon. We're extremely honored and privileged. And I think without taking too much time, I would just like to give you a very brief introduction about our university. See, we started in a very humble way in 1996 as a small engineering college located in Bhubaneswar. But then we slowly grew. We now have 10 different streams of institutions, including medical, dental, and law, management, agriculture, and veterinary sciences, and also hotel management. And we were converted to a deemed to be university by an UGC order in 2007. And since then, we have done fairly well. And you will be happy to know that in this year's NIRF ranking, we are at number 14 in the list of universities, and we are within the top 25 in the overall ranking. Also, our medical school and dental school and law school and management school, they have all done very well. As a matter of fact, the dental college and the law college are both within top 10 in the country. And this has happened not only by wholehearted contribution of all the members of the Siksha Anusandhan community, which is, in short known as SOA University. They all contribute together. But a very important factor is that we have had the blessings and participation of illustrious people like you, distinguished persons, scientists like you, who have continued to contribute to our academic ecosystem and continue to encourage us in doing better and better. With these words, I welcome you, madam, once again to this forum, and I welcome all the participants to relish the forthcoming stellar talk by madam. Clusters of stars you are going to see, I promise you that. With that, thank you, and good afternoon, and thank you very much.
Thank you, sir. Thank you very much. So today's topic is astronomy from ground and space, my journey. So I request today's speaker, Professor Dr. Annapurni Subramaniam, to kindly deliver her lecture. Madam, for your kind information, we have close to 150 viewers, and here physically more than 20 students are present, mostly girl students. So definitely they will be interested to know briefly about your journey as a scientist also. With these words, I again welcome on behalf of the university to you to kindly deliver the 11th SOAFAL 4 series of oration. Thank you, madam.
Thank you so much. You're able to hear me, right?
Yes, madam.
Yeah. Thank you so much for inviting me to give this talk, and I'm really honored to do so. So shall I go ahead and share my presentation?
Yes, ma'am, you can share your presentation. And yes, if possible, kindly make it full screen. Yeah.
Yes.
Thank you so much.
Yeah. So thank you for coming over to my talk. So I'm Annapurni Subramaniam, currently the director of the Indian Institute of Astrophysics. So I have put a background picture which is taken from space, like the space mission by name James Webb Space Telescope has captured this part of the sky. And in this talk, I will be talking about astronomy from ground and space. And with respect to my journey so far. So when you talk about astronomy or astrophysics, one thinks of sky and cosmic objects and things out there in the outer space. So it's a space science, and it's one of the ancient sciences as well. But previously we used to practice or look at the sky and observe the stars, what we can see with the naked eye. But later started using telescopes, and we started making bigger telescopes and setting up observatories on the ground. But later, with increasing space capability, we also started launching space telescopes, putting telescopes in space. And now we have powerful telescopes out there in the space. And this picture, which contains mostly of galaxies and not stars, is taken by one such space telescope, the James Webb Space Telescope. And you can see a lot of different shapes, right? You can see some red elongated object, etc., a spiral shaped galaxy, etc., etc. So two things you can observe here. One is that instead of stars, there are lots of galaxies in this part of the sky. And these galaxies are of different shapes. Generally, you talk about galaxies of shapes like, circular galaxy or a barred spiral, or, it's an ellipsoidal kind of a thing, etc. But over and above all these shapes, you also see some galaxies are stretched, like distorted. Some galaxies, like someone talking about if you can see my cursor, you can see something which is kind of elongated. So these galaxies are quite elongated. Now, the question is, why are these galaxies kind of sheared? Like, why this looking like weird shapes? So these telescopes, though, each actually captures the picture of the sky, and that one picture can tell you about a lot of things which is happening out in the space. So that is what is astronomy and astrophysics about. Astronomy gives you information about what is there in the sky in terms of pictures, a number of galaxies, etc. But astrophysics is when we try to understand why they are the way they are using mathematics and physics. So a combination of observations plus additionally applying maths and physics to it is a combination of astronomy and astrophysics. Now, going to my next slide. So since the time of Galileo Galilei, the observations have been carried out from the ground using telescopes. So that's the first time in 1609 when we pointed a telescope towards the sky and realized that we can actually see much more than what the naked eye can tell us about the sky. So he started looking at sky, and then people started looking at using the telescope to study various things. And over the last 400 years, more than 400 years, we've been doing that. And ground-based telescopes are set up at various places, including there are many in India as well. So the picture on the right is a picture of the 2-meter Himalayan Chandra telescope, which is operated by the Indian Institute of Astrophysics. And this is located in Ladakh, in a place called Hanle. And it is a very remote place. And similarly, other observatories are also in remote places. And you may ask, why do you want to keep them in very remote places? Because the ground-based telescopes require the sky to be clear, and also you should be able to see the stars, very faint stars. So what is the requirement? You should have a stable sky, and there's no turbulence in the sky, and also clear nights. So the Himalayan mountain range beyond the front, the lower ranges are good for our sky observations because they are dark, the sky is dark, and we get more number of clear nights. So there are the thousands of ground-based telescopes across the globe which operate, and astronomers are able to view the sky continuously and new knowledge every day. And this has been the workhorse for astronomers. But as you see, the sky is not like it can get clouded out, and also there are turbulence in the sky, in the atmosphere, which actually degrades the images. So these are difficulties in attaining the maximum efficiency for the ground-based telescopes. So we should be looking at the sky, but there are more reasons for why we should put a telescope in the sky as well. So going to the next page, my early career started with days in the Vainabapu Observatory. There is some noise from behind. I think someone has to mute or something. Am I audible? My voice is clear, right?
Very clear, madam. Very clear.
Okay.
Please continue.
Yeah, thank you. So this picture is from the Vainabapu Observatory, which is in the southern part of India, which is near Vellore. And the observatory is set up in around 1970, and the 1 meter telescope was established in 1972, and the 2.3 meter in 1986. So when I started my thesis work from 1990 onwards, I used both these telescopes for my observation. So now, when I had to take data, we have to go to the telescope to take data. So this is actually kind of a remote place. It's in the Jawad Hills. So obviously, when I started my journey, my mother was not very happy that I spent a lot of nights in a very remote place where there won't be anybody in the telescope or only a couple of people there. And I'll be one of the very few female there. But there would be other female astronomers who would come and go. So it's not that I was the only woman there. But then sometimes in the whole building, I'll be only one, and around surrounding place, I'll be only one there. But the atmosphere it was very, very good. So in order to make her comfortable, that I agree that I spend a lot of time here, I took her and showed her the observatory. And she talked to people and realized that, they're very, very nice, and make sure that everybody is comfortable, and make sure that the scientific journey is quite supportive. So I spent a lot of time, my thesis time between 90 to 96 in this observatory. My thesis supervisor was Professor Ramsagar, who would come for observations and teach how to perform various calibrations and various operations and how to do this. So there's a lot of discussions with my supervisor happening during the experiments itself. So I gained a lot of knowledge regarding ground-based telescopes during my stay at the observatory in Kavalur. So if anybody wanting to go to this place, you're welcome. Visit to this observatory is possible. So what do I study? I started studying groups of stars. So if you look at the night sky also, you might be, if any one of you are familiar with the objects in the sky, like the Pleiades or the Hyades, the Kritika, Nakshatra, etc. So they are groups of stars, and when so these groups of stars tell us a lot of interesting science, because when stars are there, they're stationary, right? As far as we see, they are stationary, but the stars do form and die, and we know that some stars explode as supernovae, etc. So the stars do have a evolution, the sense that they form and then they burn. They make energy, create energy like the sun. The sun creates energy by nuclear fusion in the core, and once the fuel is exhausted, they die as white dwarfs or neutron stars or black holes. But how do they evolve and die? I mean, studying the evolution of these stars was my PhD project, and we realized that just like one human, if you want to study the human evolution or human life cycle, you also live a human human lifetime. So you cannot do entirety, but then you look at population, kids to study the young population, the adults to study the middle age, and the older to study the old age population. So you should select stars which are in different ages and then study how they are. Now, how do you know how old they are? How do you find their ages? That is when the group of stars make a very important contribution, because if you look at them as a group, you will see their sequence. You can see the plots which are shown on the left, that they make a sequence. So if this particular thing, you can see the stars on the sequence are populated very well. So you can see that the stars, we can mark their masses. So there are stars which are of various masses sitting on this curve, which means that they are producing energy similar to the sun. But if you look at the cluster on the group of stars on the left side, you can see that some of the stars have deviated out of this line. which means that these stars which are more massive have disappeared. That means they have died. And the sequence which stops here tells you that stars more massive than have actually evolved and died. So if you want to create these kind of diagrams which tell you the age of the group of stars, then you have to study the groups of stars. So when I started my thesis, about a few hundred of them were well studied, and not many of them were studied at all. So we used these telescopes to take images and then create these diagrams, and then use the models to get their ages. So one of the things activities was to actually age date, get the ages of these clusters, and second, study how they evolve. Like, can the other models and the observations what we see are in tune, or do we have to make sure that do we understand them well? So that was a question which was raised. Now, if you look at 30 years after after I completed my thesis work, much better data is available, which tells you that this lower diagram, there are many stars which are younger, but then there are some stars which are evolved off. So we study many such things, and we also create various models which are shown on this diagram. And there are single stars which actually we know how they form, how they spend their lifetime, and how they die. But the question which I did not address then was, what happens when two stars are formed together? Do they do they do they kind of define how the other one evolves? So how is the binary stars, or the two stars when they bond together, interact and decide their fate? How do they interact with each other? So that's the question which I've been recently studying. So I also do study some nearby galaxies. So this is a picture take of the night sky. You can see the kind of streak here. So this is something similar to the second image I showed you from our 2-meter telescopes. This is our galaxy. So these are a Milky Way. But you can see two patches here. These are our nearby galaxies, and there's a comet. So all are projected, but these two are galaxies which are far away. But we now know that though they are kind of separated in the sky, but there is a huge plume of gas between them. So if you look at the hydrogen gas, the map of hydrogen gas between them, they are actually very well connected. So now we know that they are interacting, and they've been going around. They go around our galaxy, or maybe the first passage, and they interact within themselves. So we know that there are galaxies. I mean, the first image showed that the galaxies are there all over the place, and the galaxies do interact. Previously, when I was a student, we thought that the galaxies never interacted, and we were trying to find galaxies that interact. But when more and more data came in, we now know that all the galaxies have gone through interaction, and we now do not even find even one galaxy which never interacted with any other galaxy in its lifetime. So how do interacting galaxies affect? Do they merge? Do they, like this, the trails you see, do they get rid of their gas? And is it good for them in the sense that, they preserve the matter within, or they actually destroy and disperse the matter? So these are important questions in the evolution of galaxies, and also how matter gets consumed in these processes. So why do we need space telescopes? When we want to study all of this, we can do it from ground. You can see that the VIBGYOR color shown here is the visible range, and this is on the y-axis is shown the atmospheric opacity, which would mean that it is 100%, means it is completely opaque. It doesn't let any photons come into the atmosphere, and the x-axis is the wavelength. So the VIBGYOR sitting over here tells you that the opacity around the VIBGYOR is minimal. Atmospheric opacity is minimal. Conveying that the optical photons reach almost the ground. But when you look at shorter photons like the violet and the ultraviolet, they are all stopped by the atmosphere. We know very well that the ozone and the upper atmosphere stops the X-rays and ultraviolet rays, protecting the life on the Earth. In fact, so we cannot collect them using an instrument set up on the ground. On the ground. So if we know that the sources, like even the sun emits ultraviolet and X-rays, and if you want to understand the physical processes, why sun is emitting these wavelengths, what is the energies involved and what are the energetics, and what are the physical processes, what like the magnetic field, etc. Then you have to place an instrument outside the atmosphere, which would require a space telescope. So that is the reason for shorter wavelength. But in the longer wavelength, also water vapor stops from getting the infrared radiation. Now, why do you want to get infrared radiation? If you want to study like planets, exoplanets, or cool material which is there in the interstellar medium, which is responsible for making stars, then you need to have a detector outside this atmosphere. So one needs to have your instrument or telescope outside the atmosphere to cover the large wavelength range. Why do you want to cover the wavelength range? Because if you just take one data in one wavelength, it doesn't tell you all the physical processes. Like we know, if you look at the sun in the visual light, as you can see the sun, the sun is very quiet and it's yellowish and it doesn't do much. But actually the sun can get very active, and the activity can be traced not in the wavelength of this, but in the shorter wavelength. So you need to have, there is a requirement. And so what we now understand is that you need to have a combination of this coverage of the wavelength, which would need a combination of telescopes from space and ground. So the Great Observatories program of the NASA and ESA, that is the space observatories of the US and the Europe, have put together a lot of observatories in space, including the very famous Hubble Space Telescope. Now the new project is the Webb Telescope, but this has been carried out from space also from early 90s. So as you can see, there is a picture of the sky taken from various wavelengths. So X-ray is looking different from the visible to the infrared. So why it is looking different? Because the physical processes by which a photon is emitted, the emission mechanism varies. So the physical condition is different and the emission mechanism is different. So if you do not take the pictures across the wavelength, you will not understand what exactly is the phenomena happening there. So the new one is the Webb telescope, which is launched in December 2021, and which will work simultaneously with Hubble until the Hubble completes its lifetime. This is the first multi-mirror telescope. I don't know whether you're able to see in the picture. This is not a single mirror. So this has got many mirrors out here. And this is the first multi-mirror telescope. The bigger telescope, it's a 6+ meter aperture. So this is made up of multiple mirrors. And this marvel is sitting in a very far distance from us. And this is an engineering marvel which is collecting pictures like the one which I showed in the first. The first slide was taken from this particular space telescope. Now, where is India with respect to this? The first space observatory was launched by ISRO, called AstroSat, and this is the first Indian space observatory. I was a calibration scientist of the ultraviolet imaging space telescope, which is the 2 yellow tubes shown here. So I have worked extensively on this project for the last about 15 years or so. So my experience with ground telescopes and the experience with space telescopes combine because of the AstroSat experience. And this is a unique combination because I'm able to use my understanding and my ideas regarding science explorations combined to produce various science results. So as a calibration scientist, I was responsible for the onboard calibrations after launch and predict the performance before launch. So what happens before launch is that you have different components you integrate together, like the picture shown here, which is the integrated unit of the AstroSat. And you can see these two tubes, and it is you can see a blue line connected to it. That's a dry nitrogen. We are purging it. So why purging? Because what is the challenge here? This is the ultraviolet instrument. As I mentioned, ultraviolet photons will not reach the Earth's surface. Why? Because it gets absorbed by the molecules. But if I'm making an instrument in the ground, then it would mean that I have to test it on the ground before I launch it. How do I test it? If I shine a UV light, the entire thing will be absorbed by the molecules in the atmosphere. So you need to have a lab which is a clean lab, which also has molecular contamination minimum. So all your optics, electronics, every cavity, every component should not have molecular contamination. So we established a clean room with controlled molecular contamination, and clean it every often. So this lab is the MGQ lab in one of the campuses, Crest campus in Hoskote, which is in Bangalore. And this is where we were integrated. So my job as a calibration scientist to actually combine the test results of each of the components within this telescope and predict its how it will function, what is its efficiency, and then combine everything and predict its how we can operate it in the space and operate it for the first 6 months. So that was my experience. So this is the team. As you can see, this is like very male-dominated team, and if you can spot me, I'm standing in one edge. So in many cases, there would be mostly male-dominated team, and there'll be very few women working on these. But that is not a deterrent. Like you don't have to worry about it. You are doing science. It doesn't matter whether no other woman is present there. You just go and do it. So that has been my motivation also. And then I do encounter various cases where I end up being one woman in the entire team. So what did it do? So during the first observations, we pointed to a galaxy called NGC 2336, and this is the near UV image. And you compare this image. This is the UVIT image with the image from previous NASA mission called GALAX. You can see that our images were much sharper and it produces much detailed information of this galaxy compared to the image on the right. So it was a very big success, and this is a ground-based image. So since then, we have been carrying out a lot of studies, and this space telescope is completing 9 years of operation, because it was launched in 2015 on September 28th. So this later, in another week or 10 days, it will be completing 9 years of its operation in space. It is still working well. Its original lifetime was 5 years, but it has exceeded that, and it is still working very well. So what do I do? As I mentioned, I cannot just use this data and do science only with it. We combine data from X-ray to UV to optical to infrared from various telescopes. You can see that we take the data from UV and high energy from space, and ground-based in the near infrared and optical, and we combine the energy to create a full energy spectrum. So that tells me what exactly is happening. I do this because if I have a cooler star and a hotter star, I can actually say that the spectrum changes, and then the cool star cannot emit in shorter wavelengths. So there must be another companion. So why am I looking for it? So I just mentioned that there are two stars which are going around each other. Can it influence the life of the other? Yes, it can. So as I explained, like there could be transfer of mass from one star to the other through a Lagrange point, which would mean that one star gains mass and the other star dies. And this process can make a star look younger. So this is the kind of stars which you've been studying called blue stragglers. And it was very difficult to detect the presence of a hot companion previously. But with this technique which we developed and demonstrated, we now detect a lot of companions to these blue straggler stars, which tells us that these blue straggler stars actually acquired matter from the companion star. So we do study a lot of star clusters which are very dense, and this is one of the survey which we have carried out. And here also we probe the nature of binary stars and stars in collision systems. But you can see that the clusters over here, the group of stars are very dense. You cannot even see the center in the optical image, but you can see the center in the UV image. But in these clusters, we believe that stars actually collide. So this is only one place in the whole universe, where the stars can actually collide. And we study what happens to them. And we believe that many of the cores of this galaxy clusters might have black holes as well. So these studies are ongoing, and then many students are involved in it. So this is one of the group photograph of my postdoctoral fellows and students who are master's students, as well as my PhD students. So I don't want to go into detail of this particular thing, but this is the kind of science I do. And this is another place where we have combined the Webb telescope image and the UV image for a particular galaxy called Stephan's Quintet. And you can see that the importance of the ultraviolet and the infrared, because this is a galaxy group, small galaxy group, which is interacting. And now you can see that the yellow image, yellow light is from the James Webb telescope, and the same telescope where which produced the image in the very first slide. And it tells you that the infrared, the cooler gas or cooler material or cooler stars, where are they distributed? Now we know that the distribution is kind of centralized and some features you can see. But where is the hot gas? Where is the new stars being formed? If you want to probe that, then you have to use the ultraviolet. Now, when we combine the ultraviolet images with the infrared images, you can see that in this galaxy 7320, there's coexistence of these yellow light and the blue light, saying that stars are being formed in a similar way. But look at this group, this couple of galaxies here, where you can see that this galaxy is out here, but then the ionized gas and the trail of star formation is actually outside it. So this is a real demonstration of a requirement of different wavelengths, imagine different wavelengths to actually understand what exactly is happening here. Now this gives you a whole picture of how this galaxies have interacted, and it has thrown out a lot of gas outside and stars are being formed there. So this is published in this particular paper. So this is one of the recent discoveries which you have made, which is also this is taken from the recent press release, and this is like the researchers discover a vampire star. So basically, we prove that there is the star which is feeding off, and not only feeding off, the feeding off mechanism happens because the star evolves. This star starts actually acquiring the mass. Now, over a time, the other one becomes bigger. This becomes bigger. So this is earlier small, then it became bigger, and then this one is left behind. Now, in this process, we also see that this particular star, which lost matter, also have its processed like barium material. The normal star, the star cannot produce barium, but this star can produce barium. So it actually ate off the barium from there. So the barium was the main tracer, which helped us to say that this is indeed a material which the star itself cannot produce, but it is actually acquired. So this is one of the recent discoveries. On the other hand, I also wear multiple hats. I mean, right now I'm wearing the hat of a director also, but I also worked on 30-meter telescope as a head of the software delivery from India. So I worked with the company called ThoughtWorks and about a product which is amounting up to 5 crore. We developed and then and delivered to the US. It's a consortium, so we delivered that. So I headed this project between 2014 to 2019. So 5 years I worked on that. That has also given me a lot of learning experience working with the industry. This is a 30-meter telescope science meeting, which I organized in Mysore. So I also did a lot of work on the science instruments for the big telescope. So this is one of those things. Now, I also have proposed for the next imaging, the next space telescope in combination with the others. And since I have large experience with the space telescope, UVIT, we are planning for like a high resolution imaging and spectroscopic telescope. So that is this one. The details are shown here, and it is basically tries to have image similar to the Hubble Space Telescope, but in the ultraviolet. So it will be a very good combination. Like when I showed you this picture, the resolution of the the sharpness, let's say, of this blue image is not that great compared to the resolution of this yellow images. So if you want to go deeper and get it resolved, you need a bigger mirror, collecting mirror. So that is what we are proposing, so that we have a edge in making ultraviolet instruments. If we make it bigger, then it actually can compete with the ground-based and the bigger telescopes in the infrared up in space. So I'm happy to share that I was a recipient of the Rashtriya Vigyan Puraskar, the Vigyan Shri. I received this on August 22nd from the Honorable President. But what's me? I have another phase, which is music. I'm a violinist and I play Carnatic violin. This is my picture playing a concert with my father. My father is a musician, so I play concerts with him. And I have a son and a daughter. They are also trained in music. My parents are musicians. This is my mom receiving an award from a TV channel. She was a professor of music. My dad has lots of students, and now here he's teaching my daughter, and she learns music from him. And my son also performs different percussion instruments. My daughter is also a dancer. She's a Bharatanatyam dancer. So it's not that I don't do anything other than science. I am a musician, and everybody at home practices music, and I come from a music family. So it's that you do carry forward what you gain from your family, your heritage, but you can also do something more than that. So did music. So a clip of my violin appears in the first Sanskrit film on the history of world cinema, the Yanam. So I've played a bit of music, violin in here, and I also continue with the artwork like rangolis. I really like to put, and I just wanted to play a bit of the music here, my violin. Um, yeah, thank you. I stop here. Sorry.
Thank you.
Yeah.
Thank you very much, madam. Thank you very much. So, listening to an accomplished showman. So, we are really privileged. I think words cannot describe the joy that I had personally when the violin piece, very brief violin piece, was played by you. And you are really fortunate to have musician parents. So you could get this. Uh, uh, Probably music is was in your genes. Yes, you had made our days actually, madam. So I think we have some time, so I will request you.
Yeah.
We can take some questions. Now the telescope that you are preparing, where a lot of other private universities I was just seeing, they have participated. This one. So TIFR, TRL, CAS, and then either Tirupati. So CAS, deemed university. So, uh, so this Indian spectroscopic and imaging space telescope, is it already prepared, madam?
No, this is under the proposal stage. So there was a call for proposal for space missions in
Ah.
2017 or 18. So based on that, we had submitted this proposal. This is given a grant for demonstration, and we have completed it. And then we are waiting go to the next phase. So now that we have, there were other missions in the planning, like the Venus orbiter mission, etc. Now that they are approved, now we think that the next astrophysics space missions will be taken up for discussion. So we are waiting for that. Yeah.
Thank you, madam. Then there is a simple question: constellation and star clusters are the same thing, or they are two different concepts?
Some constellations are clusters, like the Hyades is a constellation, but it's a cluster also. But all constellations are not clusters.
Okay, madam. And the another thing is that the new class of white dwarfs in star clusters, the end product of binary star evolution. That means one star will be engulfed by the other star. That means the other star actually survives at the expense of another star. It becomes big. Its radius becomes 1.4 solar mass. Then, like that, in that process, it will become a white dwarf. Am I correct? Is that the way, or it's something different?
Yeah, so sorry, I just want to see any other slide is available. No, I'll explain this slide. So a star normally, like the right extreme here, the star actually, like if you take up as the sun, it becomes a red giant, and then it ends up as a white dwarf over here. And then the white dwarf mass can be anything between 0.45 solar mass to 1.4 solar mass. So the end product white dwarf can have mass between 0.5 to 1.4. But what we are trying to say here is that that is if you leave the star alone. But if there is a binary, then if they are close enough, then a matter can be transferred from one star to the other. So what happens is the star which is starting off from here as a B, which is actually having a lesser mass, which will gain mass and becomes B here, sitting here, which is which has a higher mass. So it will end up producing a little more a heavier white dwarf, but the white dwarf composition will also differ.
Okay, madam. For
But
our young,
if it is very close together, it can also merge.
okay. For our young viewers, please explain. That means how the two competing processes. One is the gravitational pull when the mass becomes very high. One is trying to pull the bigger mass to as small as possible, and there is the thermonuclear reaction which is trying to pull it outward. So, in the process of these competing two processes, how the star evolves. So I think because we have got students of various background, so in the process, I think if you can slightly explain it more, it will be beneficial for their understanding.
Yeah, so basically, I don't have a slide on that, unfortunately, but what I can tell you is that if what is a star, right? So we have planets, we have stars, right? So we have planets are those which they could be different type. I mean, let me first explain stars. So stars is something which produces energy by itself. Now, how is it happening? It's not like a kind of a rocky, a solid sphere. It's not like that. It's a huge ball of gas. Because it's hot, it's in a plasma state. It's a huge ball of plasma. Now, this huge ball of plasma, how do you why doesn't it just disappear and dissipate and disappear, right? So it is confined by gravity. Now, so if it is confined by gravity, how does it collapse? It can collapse. So how it starts becoming, it falls on under its own weight. Now, once it starts falling under its own weight, the potential energy gets converted into heat, half of it is. So it becomes hotter and hotter. So when it becomes too hot inside that, it can actually produce nuclear reactions like fusion. It starts producing energy by fusion. Once the energy is produced, this energy, the radiation pressure, stops the infall. So a star is always at two forces are competing there. One is a gravitational collapse, the other is the radiation pressure. If the radiation pressure exceeds, the star starts becoming bigger. That is when it becomes giant. But when the collapse increases, then it actually becomes, the size becomes smaller and it dies. So from the birth to the death, these competing forces will decide how the star and spends its life. So it's a huge ball of plasma controlled by gravity and radiation pressure. That is the star. And it is producing energy because of nuclear reaction. And the photons which are producing from the center gets interacts with the matter, and then it leaves the surface. That is when we see the star is shining, or rather emitting light. And when these forces change, like the nuclear reaction in the center reduces, then the star becomes a giant. It becomes a big star. But when it is not able to produce any more nuclear reaction at the center, then the star dies, and then the entire thing collapses. It can be a white dwarf when like the sun dies. or when a bigger star dies, it can be a neutron star, or it can be a black hole, because it's just the how much matter it is available in the sun, sorry, in the star, decides the end state of that star as well. Hope it helps.
Thank you, madam. Thank you. Then maybe we will take a question in the chat box. From your perspective, advantages and limitations of ground-based observatories compared to space-based observatories. Maybe you can take the question, Kapul. I also wanted to know what the challenges India is facing in development of such high-quality satellite like James Webb Space Telescope, etc. Even when the cost of production in India is way optimized than other countries. So first, you can take the first questions, madam.
Yeah, so observatories we have, I mean, I spoke only about the optical observatory, but we have radio observatory as well on the ground. But in the case of optical observatory, the main impediment is the challenges are the light pollution, because the city lights, and then I see when I grew up as a child in a interior place, and not so interior in Kerala, the night sky was very brilliant. And I got inspired, and I actually took up science and astronomy, because I used to look up at the sky and actually used to want to do. So that inspiration, if you want to look at the night sky and identify constellations or clusters, I don't think anybody can do it, because every night sky, every sky in every part of India is most of the part of India is very polluted. So you can hardly see the sky. Inspired by looking at the night sky is kind of reducing. So the main thing is that this is a natural, it's a beautiful night sky, and preserving the night sky has become very important, and the observatories also face this pollution. So for that matter, the observatory here, Himalayan Chandra Telescope, is located at Hanle. 30 kilometers around this area is now kind of notified as the dark sky reserve. So we are implementing controls for light pollution so that the night sky is preserved. Not only the night sky, it's in wildlife also, the flora and fauna can also get preserved, and people can come here and enjoy the night sky. So we have been seeing a lot of people coming here, tourists and space enthusiasts and astronomers coming, or rather amateur astronomers coming here to enjoy the night sky here. Regarding space programs, it's very expensive, all said and done. But if you want to create something like these kind of space programs, you have to have not only the challenges to make the components, but the entire system to integrate and put it. You need to have a lot of infrastructure, and this huge infrastructure has to be created, and it's not like a one-time thing, right? Like if you want to create a huge clean room to integrate the entire thing, now if you making the entire clean room for one mission, it is not viable. You need to have, it's not only one, but it's which way to go. You need to have many small missions, or you want to have a few big missions. So integrating small missions and big missions together and have a visionary goal where both are integrated, and so that you can set up the infrastructure and use all this infrastructure and develop human resources properly, has to be in place, without which we can't endeavor take take a step in this direction. For that matter, the Gaganyaan program, for that matter, you need to have many missions, and then only you can eventually have a Gaganyaan as well as the Bharat station, etc. So in entirety, you will have to have some 10 missions up and test each and everything, etc. So each and every mission, if you want to get approval, then you are not getting the vision of the entirety of the program and where we are achieving. Only if you see the entirety of the program, you'll be able to plan it and execute it properly. Thank you.
Thank you, madam. Then I think you might have answered this question. I also wanted to know what the challenges India is facing in development of such high quality satellites like the JWST. So I hope you have answered that question, madam.
Yeah, I've already answered, yes. Yeah.
Okay, and then probably another question is there. Please give an idea about how much it costs to put a satellite into orbit.
Can you repeat it? The voice was not clear.
Am I audible, madam?
Yes, that word I couldn't catch it. Can you repeat?
Please give an idea about how much it costs to put a satellite into orbit.
Okay. Yeah, so this is the right slide. So the cost of this mission is broken into various parts. So first you need to have the planning and etc. But even in the launching, you need to start the costing from the the rocket, the launching rocket costs, the instrument making of the instrument cost, and you also have the operational cost and the communication cost, and so all the peripheral. So even if you look at a I don't know whether you can see it here, these telescopes are integrated into a particular hub. This picture, you can see that, right? So there is a big control station within this observatory. So you attach these telescopes and the instruments to that observatory, because that has the central computer which tells what is to be done, communicates with this thing, etc. Right? So that's called bus. So the rocket, the bus, the instruments, the operation. So everything has to be costed.
Okay, madam. Then there is another question. What determines how galaxies interact with each other?
Yeah. Okay. So in this picture, yeah. So galaxies normally are found in clusters, and they interact with the nearby ones, but they do move around in this particular potential well of the cluster, and then during the path they come across and then starts colliding. So it is quite natural that the galaxies are generally found in small clusters and small groups, and interaction is inevitable. And interactions can be direct collision or it can be passing by. So in the case of this, there have been constant collisions, but in this case, the other Large Magellanic Cloud case, yeah, here this actually going around each other and not merged, but in the future it will eventually merge. In the process, you can see this trail, gas trail. You can see this double helix thing here. You can clearly see it here, which means that the galaxy has actually gone around, and this is the trail. The trail is actually intertwined. So eventually the entire gas will engulf and these galaxies will collide. So this is gas rich systems, but sometimes you can also have collision with galaxies without gas. So that will be just dry merger.
Thank you, madam. We will take a few questions from the audience. Yes, please ask your question.
Good evening, ma'am. Myself Amruta Saho, and I'm an agriculture student. So, as we know that GPS, GIS, remote sensing, along with soil information systems, are common words in agriculture sector, and it is directly related to the satellite and space. So, I want to know what are the major changes that we are going to see in the future years, or the recent changes in the space, which is going to affect us or challenge us in the future years.
Yeah, so in the case of a history of Indian space program, the earlier years and also now, the focus is for benefit for the community. So how the science and technology and space technology we have understood can help in day-to-day life, including agriculture, the flood relief, climate changes, and the natural disaster, the fishing industry, etc., etc. So you can map the ground from space very clearly and actually say how to provide weather updates and drastic weather conditions, warn against drastic weather conditions, and also help in identifying resources, including water, and also including change in vegetation pattern across large areas, which cannot be done from the ground. So in the case of agricultural sector, the cadence and as well as the hyperspectral imaging, which has been the keyword these days, can provide large amount of data regarding individual things. So I think the weather satellites which have been launched recently, as well as the hyperspectral imaging information which is going to come very soon, will really help in the agricultural sector with respect to precise weather predictions, as well as with respect to water resources and vegetation. This is my limited understanding. Yeah.
Thank you, madam. Now I think we will take the last questions. If anybody have any questions, so we'll take your question. Last questions.
Very good evening, ma'am.
myself Chitraleepi Nayak, and as we saw that you belongs and hails from a very culturally rich family, I would like to know how you balance both the things together, being an astronomer as well as an artist.
Yeah, so see, I believe that one has to pursue whatever you're passionate about in life. And if you do something which you're passionate about, you like very much, then you really don't mind putting in, spending in time and effort. If you start feeling the pressure and saying that you're really tired and you can't do this anymore, only when you try to do something which you don't like. So since I like both doing astronomy, that's doing science, and doing music, and I really don't, I am able to manage both. And it's not easy that you can keep doing at together all the time, but sometimes I will not be playing violin for a while, but then I get back to it, saying that, oh my God, I haven't done it, so I'll just get back to it. So it's possible. It's just that you need to because I mean you need to love it to do, and I think definitely people can do it.
Thank you, ma'am.
Thank you, ma'am. Thank you. Actually, one last question probably. So, since how long you are playing violin, madam?
Since my young days, because I learned singing initially, but I took to violin about 7 years or 8 years, or
And
maybe.
doing violin concert also.
Yeah, so my parents are musicians, so at home music all the time, right? So I learned, I know how to sing, and I used to sing, but now I don't sing. But
Why I'm asking these questions? My younger son also plays violin. So, what kind of violin are you? Have you any imported violin, or you have violin in India?
when I started playing violin, I used a 3/4 size, but my daughter started playing violin when she was 4 years old.
So you have imported violin from
So we got a quarter size violin. You get
outside.
quarter size, yeah, quarter size violin.
Nachiketa, can I add something here?
Yes, yes, please, Divakarji, yes.
Uh, Good evening, Prof. It's very pleasant to see you. Ram Sagar, your mentor, recently did a harate with us at the for TAC, and I'm waiting to invite you to hold another harate with us at the academy. But in the meantime, Nachiketa ji, I wanted to extend this music and science thing for the benefit of all the students. See, almost all good scientists are also good musicians. Whether
Yes,
it is
yes.
both of the Bose and Einstein, both used to play. Einstein used to play the violin. Bose used to play the sarod. Richard Penman. Most of the good scientists, they're also good musicians because music contributes to the development of your, thinking in scientific ways. Classical music, especially.
And Handel probably playing the drums and the tabla, I think.
Yes,
Yeah?
yes.
And
It's actually very connected. Music and scientific thinking is very connected.
yeah, Sir C.V. Raman has written even scientific papers on percussion instruments as well.
Yes. So I would welcome people to come. In fact, IIA very strong outreach set. And one, I know it's beyond time, but could you, for the sake of the students, clarify a little bit research going on? Could you give an idea about why we need so many institutions doing the same kind of research subject, and what differentiates it a little bit, if you can give an idea?
Yeah, so I did not put a slide on the history of our institute, Indian Institute of Astrophysics. Basically, it dates back to 1792, when an observatory was set up in Nungambakkam in Chennai. So that observatory was there to actually, record various things and also study the sun and total solar eclipse and the planetary transits, etc. And that observatory had a lot of ancient instruments. British established that, and a lot of Indians were working at that as well. And you remember around 1860s, the total solar eclipse, which actually led to the detection of helium in the sun. That happened in India. And later, in 1899, the observatory moved to Kodaikanal. The Kodaikanal Observatory in Tamil Nadu is established in 1899 and it's completed the operations of 125 years. So there's a lot of heritage which has been there in the country in terms of astronomy and astrophysics, observations, instrumentation, everything was transferred to Kodaikanal. And the Kodaikanal has a huge heritage and also the library there, and also there are a lot of ancient instruments we have. And then it became Institute of Astrophysics in 1971, and we established a lot of observatories beyond that. Now, astronomy and astrophysics used to be a very confined topic because people could carry out only observations from these and take data from these observatories. But in the last 30 years, we have seen something called data democratization. Because like people who do not own telescopes, people who do not know anything about data, I mean, how it is acquired, you can actually do a lot of space science research. We see a lot of interest among school children, college students, everybody wanting to do, something on space science. I want to do some research on space science. How do I do an internship on space science? Now, we do not have enough astronomers who can actually train people. Now, astronomy also has a lot of other hidden the things, in the sense that it advantages, because astronomy, in fact, drove the data science, and the amount of data which is available in astronomy actually drives the use. Even for my thesis, I have used neural networks as part of artificial intelligence. So large data requires, classification, etc. And the detector, communication, all things come from astronomy. So astronomy is part of fundamental science, and I think the number of institutions in the country is still limited, like, IUCAA, AA you mentioned. But if you can see in my slide, Christ University, actually deemed to be University Christ, has set up a nice astronomy center, actually, the Center of Excellence in Astronomy. There are very good astronomers there. Recently, Manipal also has a astronomy center, and Ashoka University, a lot of astronomers are there now. So space science is spreading quite a bit. Ahmedabad University has people in astronomy and astrophysics. So space sciences has become very attractive. Kanpur, IIT Kanpur actually started a department of space sciences and engineering. Many IITs are starting that. So space sciences have been confined to small institutions, but now it has become quite widespread because the technology and science are combining together, and we have more and more opportunities. Larger programs coming up, LIGO, which is happening in the country, and India is partner to large missions, which I did not touch upon because the gravitational wave observatory is coming up in India. So exciting times ahead.
Also, the Mysore extension of IIA itself.
Yes, we are setting up the
That's another
planetary
lovely initiative. Yes.
Yeah. So it's a lot of activity and a lot of interest, and we look forward to more participation from students and interested people in the future. Engineers, of course, yeah.
So Nachiketa ji will probably initiate something in his university now, hopefully.
Yes, definitely. That's why I asked Madam earlier, so how Kashmir University participated in that proposal. So I have that in mind actually. So I will also invite Madam. She is coming to the NISER annual function in November 7. Are you coming, Madam? Probably the.
Happening at NISER, if you are you attending, ma'am? Is this question?
No, I'm not attending. Yeah, I'm not.
Okay, so Subhankar ji probably will agree with me that at the end, all of you are expecting a longer play of the violin. It was so soothing after the. So next time, please keep at least 1-2 minutes of violin, please, madam.
Yeah.
So thank you very much. And on behalf of the university, outreach cell, academic trust, and everybody, we are so happy and grateful to you, madam, for this beautiful lecture. And which was the violin was icing on the cake. Thank you very much. We are so. Please accept our pranam. Thank you.
Madam. Thank you.
Thank you so much, bro.
Bye.
Bye. you.